Hello friends, welcome back. Today we are solving longest palindromic substring. As usual, we'll start with the problem statement. Next we'll look at some examples. After that we'll discuss the brute force approach to solve this problem that has the runtime of O of n cube. We'll optimize the brute force approach to make it an O of n squared solution, and we'll optimize it further to make it an O of n solution, which happens to be Manacher's algorithm. Finally, we'll write the Python code for Manacher's algorithm. If you're enjoying the content, please don't forget to subscribe to the channel. Your support means a lot. Drop a comment below suggesting topics you would like me to discuss next. Let's get started. Given a string S, return the longest palindromic substring in S. A palindrome is something that reads the same backwards. In the example 1, the longest palindrome is either PAB or ABA. We can return either of them. In the second example, longest palindrome is BB. Let's look at a different example and solve this using brute force approach first. Here is another example, and the longest palindrome in this example is this. Brute force way of solving this problem is to consider every possible index pair. For example, 0, 1 is an index pair, 0, 2 is another index pair, 0, 3 is another index pair, so on and so forth. And for each index pair, we have to check if the substring represented by that index pair is a palindrome or not. Let's consider the index pair 0 and 3. And the substring represented by index pair 0 and 3 is this. To check if this is a palindrome or not, we have a left pointer pointing to the first character in the string, and we have a right pointer pointing to the last character in the string. We compare these two characters, and if they are equal, we move the left pointer to the right by one step, and we move the right pointer to the left by one step. We continue doing this until we meet one of these two conditions. If the character pointed to by the left pointer is not equal to the character pointed to by the right pointer, then the substring is not a valid palindrome. But if we reach a condition where L is greater than R, that means the two pointers have crossed over each other, which indicates that the current substring is a valid palindrome. In this case, we compare this palindrome length to the previously found longest palindrome. If this is longer than the previous palindrome, we save this into result. And we continue this for all possible index pairs. So the total runtime of this algorithm is there are n square such index pairs, and for each index pair, it takes O of n time to check if it's a palindrome or not. So the total runtime complexity of brute force approach is O of n cubed. To optimize the brute force approach from O of n cubed to O of n squared, we need to look at the palindromes more closely. There are two types of palindromes. One is a palindrome of odd length, and the other is a palindrome of even length. For example, this palindrome of length 5 is an odd palindrome, and this palindrome of length 6 is an even palindrome. Let's consider odd palindrome first. To check if this is a palindrome or not, we started from two pointers that pointed to the outermost characters in this substring, left pointer and the right pointer, and compared these two characters and kept moving left pointer to the right by one step and right pointer to the left by one step until they cross over each other. Another way to check if this is a palindrome or not is to start from the center and expand it outwards. In the beginning, both left and the right pointers point to the same center character, and we keep moving left pointer to the left and right pointer to the right by one step as long as these two characters are the same. We can do the same to check if a substring of even length is a palindrome or not. But the center for the even length substring cannot be one of the characters. It has to be the gap between the character. For example, like this. So the left pointer points to the first character to the left of the divider, and the right character points to the first character to the right of the divider. And rest of the method remains the same. we keep moving left pointer to left by one step and right pointer to right by one step as long as these two characters are the same. And we stop moving them when we find two characters that are not equal. So let's apply this method to find the longest palindrome in the given input string. To find a palindrome of odd length, we can start from any of these characters and expand these left and right pointers outwards. But to find the palindrome of even length, we have to start from a gap and have the left pointer point to the first character to the left of the gap and the right pointer point to the first character to the right of the gap and repeat the process. So to make our life simple, let's represent these gaps by an unique character. So here is the same string, but now we have replaced all the gaps such as here with a special character hash. Now we can start from any of these characters. For example, let's say we start from A over here. Both our left and right pointers point to this character, and we can keep expanding until the characters pointed to by these pointers are not equal. L and R are equal right now, so we move them to the left and the right by one step. L and R are still equal, and we repeat this process. When we expand L all the way to over here, and we expand R all the way over here, we started from the center character. Now L points to D and R points to A. These two characters are not equal. So the longest palindrome, starting with this A as a center character, is this. And the length of this palindrome is R minus L minus 1. If this is the longest palindrome so far, we save it to the result. Next, let's say we start from this character as a center character. Both L and R point to this character, and we keep expanding L and R outwards until we find two characters that are not equal. We kept expanding L all the way over here, and we kept expanding R all the way over here. L points to B and R points to D. These two characters are clearly not equal, so the longest palindrome with this as the center character is this. And again, length of this palindrome is R minus L minus 1. In this palindrome, if we get rid of all the hashes, we get, and as you can notice, this is a palindrome of even length. So just by inserting a special character in all the gaps and then starting from each character as the center and expanding the left and the right pointers outwards, we can find all the odd palindromes as well as the even palindromes. So the total runtime complexity of this algorithm is, in total, there are 2n plus 1 centers because we started with n characters and we added n plus 1 special characters which are hashes. So there are 2n plus 1 characters in the new string, and we can start from any of these 2n plus 1 characters as center and expand outwards. So this expanding outwards also takes 2 of n plus 1 time. So the total runtime complexity is big O of 2n plus 1 whole square, which is on the order of big O of n squared. Now let's see how to optimize this even further to make this an O of n algorithm, which happens to be Manacher's algorithm. So previously we started from this input string s, and we added a special character hash at all the gaps to get this new string s prime. And on this new string s prime, we ran this algorithm where we considered each character as the center, and from the center we expanded the left and the right pointers outwards until we found two characters that are not equal, and we saved the longest palindrome. So let's write down the longest palindrome possible at each of these characters in S prime as the center character. So after running the previous algorithm on S prime, this table has the longest possible palindromes at each character as the center. Let's consider this character D, and length of the longest palindrome is 1, which means with D as the center, it has one character to the right and one character to the left. So this table represents how many characters are to the right and to the left of each character as center. So the palindrome here is this. Similarly, let's consider this character B. And the table says we have 3 characters to the right, which is 1, 2, and 3, and 3 characters to the left, which is 1, 2, and 3. So the longest palindrome with B as the center is this. Similarly, let's consider this character, and the table says that the longest possible palindrome with this character as the center has 6 characters to the right and 6 characters to the left. So the longest palindrome is this. If we removed all the hashes in between in this longest palindrome, we get this, which is the answer. So now, what can we observe in this table that will help us reduce the complexity from O of n squared to O of n? Here is the same example again. Let's say we have already applied the previous O of n squared algorithm to all these characters as the center character. And we have filled this table with the length of characters to the right and to the left of each center character that forms the longest palindrome. And right now, we have to find the longest palindrome with this character as the center character, and let's call this I. Just for the simplicity, let's mark the longest palindrome we have found so far, which is this. When we start from B, the usual O of n squared algorithm is to have a left pointer pointing to this character and the right pointer pointing to the same character and expand them outwards, which takes O of n time. But do we really have to start these left and the right pointers at this character B? What if we could start these left and the right pointers from here? Then we can save these 3 comparisons. But how can we directly start these left and the right pointers all the way over here instead of starting from the same character? For that, we need to look at the table so far. And from the table, we can tell that this character over here has a palindrome that has 5 characters to the right and 5 characters to the left. And the current character B is part of the right half of this previous palindrome. Because we already know that the characters in the right half are the mirror images of the characters in the left half, we can deduce that there must be a mirror image of this B in the left half. The way to find the location of the mirror of this character B is using this formula, where C is the center of the previous palindrome, which is this character, and I is the current character we are processing, which is this, which is 2 times C is 7 minus I is 9. So this would be 14 minus 9, which is 5. So the mirror of the current character B at index 9 is at index 5 on the left half. And the corresponding value of that mirror character B in the table is 3. That means the longest palindrome that we could form with the mirror B as the center character has 3 characters to the right and 3 characters to the left. Hence, we can just copy this 3 into the current character B and say that we already know with this character B as the center, we can form a palindrome that has 3 characters to the right and 3 characters to the left. This is not the longest palindrome yet, but we at least know there is a palindrome that has 3 characters to the right and 3 characters to the left. Hence, instead of starting the left pointer and the right pointer from this character B, we can start our left pointer over here and right pointer over here, because we already know that this is a palindrome. And with this new L and R, we compare the characters and expand. Unfortunately, in this case, these two characters are not equal, so we stop the search. Let's consider an edge case in this. Let's say we have found the longest palindrome for all these characters as center character. And right now, we are finding the longest palindrome for this character as center character. And from this table, we also know that the longest palindrome we have found so far that extends to the right the most is the palindrome that centers at this character. It has 6 characters to the right and 6 characters to the left. And this is the center. Since the current character is part of this palindrome, we know that there is a mirror of A in this palindrome. And we can find that using 2 times C minus I. C is the center of the palindrome that extends to the right the most, which is equal to 2 times C is 12 and I is 17. This is 24 minus 17, which is equal to 7. And the mirror of the current character is this. And what we did previously is we just copied this value to here and started our search with left and right pointers from the 6th character to the right and the 6th character to the left. So the left pointer for the current search will start from here, and the right pointer for the current search would have started from here if there is a 23rd character. But if we look at the substring between this left and the right pointer, which is this, and this is not a palindrome centered around this character with 5 characters to the right and 5 characters to the left. Why did this fail? It's because we saw that this mirror A has a palindrome that has 5 characters to the right and 5 characters to the left. But what we missed is palindrome of this mirror A is not part of this original palindrome. So the palindrome of mirror A has 5 characters to the right and 5 characters to the left. So this palindrome is not completely within the original palindrome we started with. So the only palindrome of mirror A that is part of the original palindrome we started with is this. This is completely within the original palindrome we started with. So instead of copying 5 from here, we should have just copied 1, which represents 1 character to the right and 1 character to the left, and this palindrome. So this 1 is also the distance between the current character at I and the rightmost character in the current window. So how can we find the rightmost character in the current window? Is by using this formula, where C is the center character and L is the length of the characters in the palindrome. So the rightmost character up to which the current palindrome extends is C, which is 12, plus L, which is 6, is 18. So the value we should fill here should be R minus I in this case. So our left pointer will now start from here, and the right pointer will now start from here. Let's call this table P. But previously, we had copied this value 3 over here instead of calculating R minus I. That's because this palindrome was fully within the current palindrome we had considered at that time. So the value we fill here is minimum of r minus I, where r is the rightmost character in the current palindrome window and I is the current character, or p of I prime, where I prime is the mirror of the current character in the current palindrome. In this example, I prime is this, which is equal to 2 times c minus I. Since this r is confusing because we also use left and the right pointers for the current character, let's write this formula just in terms of c and I. We know that r is equal to c plus p of c. And we know that I prime is equal to 2 times c minus I. Let's plug these two into this formula. So for the current character I, we start from left and the right pointers to search the longest palindrome from I minus p of I minus 1, and right pointer will be I plus p of I plus 1, where p of I is here. Let's outline the Manacher's algorithm. Let's review Manacher's algorithm again. Like the previous approach, we want to find the longest palindrome for each and every character as center character. So we start from c equal to 0, which means the palindrome that extends to the right the most has the center c equal to 0. And we have initialized the length of the palindromes for all the characters as 0. So we process each character one by one. First, we check if this character is part of the previous palindrome that extends to the right the most. That is, we check if I is less than the rightmost character of previous palindrome, which can be found using c plus p of c, where p is this array over here. If that's the case, we fill p of I equal to minimum of length of the palindrome of its mirror character, or the distance between the rightmost character in the previous palindrome minus I. If the current character is not part of a previous palindrome, that means we set p of I equal to 0, which is similar to expanding from the center. Next, we set left and the right pointers to this, and we expand outwards until the characters pointed to the left and the right pointers are not equal. If we found a new palindrome whose right pointer extends beyond the right pointer of the previous palindrome, then we set the center to I, and we repeat this for all the characters. After this, our array P over here will be filled with the longest palindromes possible at each character as the center character. Now, all we have to do is to find the maximum value in this array and the corresponding index. That gives the center character of the longest palindrome. From there, we find the starting index of that palindrome and get rid of all the hash characters in between. So that's our longest palindrome, and the runtime of this algorithm is O of n, because we are cutting down on all the additional comparisons we used to do if the current character is part of a previous palindrome. If the current character is not part of a previous palindrome, then it is similar to expanding from the center, so we expand the rightmost edge of a palindrome. Because we extend the rightmost edge of a palindrome only once, the runtime of this algorithm is O of n, not O of n squared. So let's write the code for this algorithm. So we start by adding the unique character hash to all the positions in between the characters in the given input string s. So s prime is equal to, let's join given input s with unique character hash and add hash at the end as well as at the beginning. Next, let's find the length of this new string s prime, and p is the list where we store the longest palindrome length. So we start with 0 to n, and c will be the center of the previous palindrome that extends to the right the most, and we initialize it to 0. So for each character in the input string, we check if I is less than c plus p of c, which happens only when if the current character is part of a previous palindrome. So in that case, we set p of I equal to minimum of the rightmost character of the previous palindrome, which is c plus p of c, minus I, or p of the index of the mirror of the current character, which is 2 times c minus I. Next, we set L, R equal to I minus p of I minus 1, and R equal to I plus p of I plus 1, and we extend this pointers outwards until we find the characters that are not equal. So while L is greater than or equal to 0 and R is less than N, and S of L equal to S of R, we increment P of I by 1 because we expanded the current palindrome by 1 character both on the left and the right, and we set L minus 1 and R to plus 1. Next, we check if the rightmost character of the current palindrome is greater than rightmost character of the previous palindrome. If that's the case, we set c equal to I, and we continue this for all the characters. Once we are done, we check the maximum length of all the characters. Let's say max L equal to this, and we have to find the index of that center character. Max of I, which is the index, is equal to p dot index of this max value. Then we have to find the start index of this palindrome, which is max I, which is a center index, minus max L, which is the length of both the halves. We divide this by 2 to find the start index in the original input string s instead of s prime, which is of twice the length. That's why we divide by 2 here to find the index in the original string. So we have the starting index of the longest palindrome, and we have the length of it. So we just return s of start I all the way from start I plus the length is max L. We don't need to divide by 2 here because max L is the length of the left half and the right half in S prime, which is twice the length. The same value for S would be the length of the total palindrome, not just the left half or the right half. So that's our algorithm. Let's try to run this algorithm. Pardon me, I have a bug here. I should check in S prime instead of S. So let's try to run this code again. As you can tell, this is the most optimal solution. If you found this video to be helpful, please support by liking the video and subscribing to the channel. I will see you in the next video. Thank you.